like 17 plus years of experience. I manage the control plane services for one of the Dhruva products. So we faced while in Dhruva, and the problem that we continue to face, right? Different issues on our SQL databases, right? So we use SQL databases for most of our applications. So we have like around 100 plus microservices, 15 plus database instances, and like around 25, like 50 plus databases itself, right? So there are a lot of databases, lot of database instances, and then there are challenges that comes with these databases, right? So the basic challenges that we came across and now how did we solve it and how we plan to solve it in future is what I'm going to talk about. Okay, so we know, right, there is a pain when we actually interact with databases, right? The pain is like understanding the database schema, what is present in the database, what are the different tables, what are the relationships between these tables and so on, right? And then like slow query. I'm assuming like everyone would be facing some slow query on production. Raise hand if not, right? Okay, good. So yeah. And then like if you're using ORM models to interact with your databases with Go, then you don't know, right, what actually query gets fired in the backend. So that's another challenge with the ORM kind of models. And finally, right, you have a lot of complex queries, you have a lot of joins involved, you have a lot of aggregations involved. So when you look at the query itself, it's like overwhelming for you to understand what does that query do. So what's the real impact of these challenges, right, on your Go applications? My bad. Yeah, so slow queries, right? Slow queries means slow APIs. It's not like if your application is fast, means your database is also fast and vice versa, right? But most of the times, when you are using Go, the Go routines are fast, but they are waiting for some response from the database, right? So ultimately, you are stuck on your database. And then like, if you have over-normalized your database, and then like you have a lot of bloated code, basically, and then it is very difficult to manage, maintain, and debug these complex table structures in your code. And finally, most of you would relate who are like actually debugging production issues, right? Whenever you have a slow query, you go to the tables. Okay, this query involves these tables. Now let's describe this table, see what are the indexes, what are the columns and data types, and so on and so forth, right? So you spend a lot of time when there is a issue, and you basically are like very deeply involved in understanding what does that query do and what are the different aspects that it uses from different tables, right? So considering this as a background, right? So this is your slow application because of slow queries, maybe. And then this is where you want to reach, right? You want an optimal application performance in majority of the scenarios, right? So how do you bridge that gap? Yeah, so SQLens. So SQLens is a tool that we have built internally that actually helps us solve most of these problems. So what we have tried to do is capture all the database schema intelligence that we have across all the instances and databases that we have. Then what we have done is like expose these database schema as an MCP server, and then it is integrated into each and every developer's ID. And then you use AI-powered analysis, reasoning, and optimization techniques to actually solve the problem, right? But this looks like a very simple path here, right? It's not that simple. So what you need to understand is what information you provide as a context to these newer LLM agents and AI agents, right? The database schema details, the tables and views. So you would have like say 50 databases, every database having like 50 to 100 tables, and then there are different views that captures different aspects of your use cases. So capturing that information, the cardinality of these tables and views, right? Then like what are the different columns that you have? What are the data types of those columns, right? What are the different indexes that you have in these tables? and what is the cardinality of these indexes, right? Then like you look at different types of database constraints like primary keys, unique keys, and basically foreign key dependencies. And finally, the character set encoding that you use and the collation settings that you use while you configure your tables, the different string data types that you have, right? So this is all the database schema intelligence. Now, how do you use it further? You use it further by basically exposing this database schema by storing it somewhere. Now you can be like, it could be again some database or it could be a document store. Basically, now we have written an MCP server on top of this database store to basically expose this schema as tools, MCP tools, and then integrated, as I mentioned, integrated with your different AI IDs like Cursor, Kiro, Claude, Gemini Code Assist, and so on, right? And then use the leverage reasoning ability to basically understand what the schema does and what are the questions around this, and try to reason and answer them. That will help you definitely to resolve your SQL issues faster and accurate. So what's the magic loop here, right? So assume that how do you guys solve it, right? You get a slow query, you analyze the query, figure out what it is using, what it is not using, figure out the indexes, figure out the joins, and so on. And finally, you come up with some suggestions, right? It's the same thing. You get an unoptimized query, you do analysis on top of that query, you figure out what are the different joins, filter detections, index identification, and then like you would come up with some index suggestions. And then you also might come up with an optimized query which may not be optimized to be in like at the first place, right? And that's the output. So this is a continuous loop, right? As and when your scale grows, as and when your requirement changes, you have to go through this loop every now and then. And finally, right, you just don't trust your AI agents and LLM agents to like just generate the right output always, right? How do you validate it? So basically, whatever output these AI and LLM agents give, you have to validate it. You have to make sure that it is working as expected. It is not changing the meaning of your query. It is not changing the semantics of your query, right? And finally, once you validate it, then you have some actionable results that you can actually work on. So how did we deploy this on our environment, right? So we have a production environment with 15 plus database instances, and we have read replicas for them as well. So what we have done is a Lambda function that actually periodically reads the schema, dumps it into a object store. And then another Lambda function in our development environment, and that actually pulls that schema, post-processes it, and then like actually stores it in a document store. And on top of that document store, an MCP server is built, which will actually read the schema for different tool calls, and then actually give out question and answers to your LLM agents, right? And then this MCP server, as I mentioned, is configured to your IDs and your AI agents. So this is how the basic schema looks like. So a basic number of tools that you can see here. SQLens is the like MCP server that we have exposed. It provides you a list of all the schemas, get schema info, search, and so on. So what just one point here, right? You would have questions in mind, right? Why production environment different than development environment, right? Again, security is a major cause of concern with these AI and LLM agents. So what I want was only metadata. I don't need to worry about data. Data can be created, tested, you can have a sandbox environment on which you can work on. But what I need is like live production schema that I can actually operate on and solve my day-to-day production issues, or even like others API related issues, right? So that's why that segregation, and then it is available now, that schema is available to each and every developer in Dhruva. And then if you can see, there is a sandbox MCP as well that we have built, where you can configure this MCP to your sandbox or your test environment and actually validate your improvements on that sandbox environment. And finally, the demo time, right? So let's try to so this is a recorded demo. So let's see, right? So here what I've built is a small application that actually on top of the employee database that is publicly available, and trying to run some API call from that application. And what happens is like it takes around 16 seconds to basically fetch that data. So what I've done is copied this query, putting it into your cursor with a defined prompt, and now I'm asking him to analyze and figure out what are the different issues in the query. So if you see, right now it is figuring out there are 7-8 steps that it needs to take based on the prompt. What it's trying to do is it is trying to fetch the database configuration, list all the schemas for this query, right? So it figured out that these are the tables present. Now it is trying to fetch all the table information related to this table. Now since we provided it a SQL query, now it is also actually trying to analyze the query on the sandbox environment. What it is trying to do here is basically trying to get all the context from the query, from the SQLens schema store, and the sandbox environment where it is actually trying to run certain analysis like analyze and explain query, and then try to come up with suggestions rather than just blindly generating something or hallucinating, right? So the goal here was to like provide the right context and the right information so that it can reason rightly, right? So what it figured out was like, okay, the original query takes around 17 seconds on the sandbox environment, okay? And then it actually re-optimized the query and it took around 2 seconds to complete it. So it's like immediately an 8x performance improvement that it figured out. It figured out that there are certain inefficiencies here. You can read it through, I cannot directly, but it figured out that there are certain inefficiencies, like there is file sort happening and so on. And now it is trying to figure out, okay, based on the analyze output, it needs to add certain indexes. So it is trying to add those indexes and then again run the query. So in an iterative fashion, it is trying to add index, verify the results, and again optimize it. And finally concluding it, saying that, okay, I am done now, I am cleaning up all the indexes that I have added. And then finally summarizing that this is the final expected output, like these are the indexes you need to add, this is the optimized query. One step that it is also doing here is like it figured out from the code that in this file, the code and the query is present. So it is going and overriding and changing the code actually, and updating the code with the latest updated query. And finally validating that by compiling it and testing it. So if you see, right, LLMs have large, or like it has good amount of power to do almost anything within a given environment, right? So you have to define what you need to leverage, what you need to get done, and then like figure out what are the use cases that you want to solve. So slow query has been, like everyone has a slow query problem, but this is how we tried to solve it at Dhruva, and it definitely has helped us here. So the slow query was just one use case here, but if you look at this, right, so we have used it for multiple other purposes, like better code reviews, right? So whenever someone is changing something or adding or changing some API, SQLens has helped us actively review whether the changes are right or not, or if you are adding certain parameters, those parameters, whether they actually will cause slow query because you have added a parameter that is not indexed, right? It also helped us build new APIs on the existing schema faster, because now it has all the context what it needs, and then like building those APIs becomes very, very easy. And finally, right, if you want to upgrade something, now you have like tools that can help you analyze your upgrade paths and figure out whether those are optimal or not, and work with them to basically build an optimal solution for upgrades as well. And like this has become a part of our culture. So since last 6 months in Dhruva, so we built it in somewhere around like April, March timeframe, and everyone, almost every developer has this configured, and I have really got good feedback from most of the developers in Dhruva. So I thought, why not share it with this Go community here? Other use cases that we are doing is like escalation and debugging analysis, right? Schema discovery learning. So if you have, say, new joinees coming in, how do you onboard them with your database schema quickly? This could be one of the options, right? We have like bi-weekly upgrades at Dhruva. So what we do is like we capture this schema periodically, and then like whenever the upgrade happens, we have a new version of the schema. So it is very easy for us to figure out what has changed from last upgrade to the current upgrade, and if something breaks, right, very easy to narrow down. Building quick API prototypes is always there. And then like one thing that we have figured out is like your SQL tables have a certain data type, and then your code has certain data types. If there is a mismatch, this has helped us figure out a couple of issues on that front as well. And then like reporting and building scripts on top of your existing databases to maybe report, say, new feature adoption or something of that sort. We very quickly, it has helped us quickly build these reporting scripts to help monitor your features on production. And that's it. I think that's it from my side.